Continue talking about how to factor quadratics, but now we are going to look at quadratics where the leading coefficient, in other words, the coefficient in front of x squared, is not 1. Previously, we only looked at the case where a was 1, or we could use one of those special cases like a perfect square or a difference of squares. So here we now are going to write our quadratic in the form ax squared plus bx plus c. Previously, we just didn't have that a because it was 1, so we can just leave it like that. And here I'm going to note that a does not equal 1 in the cases that we're going to look at. So just like I've been saying over and over, factoring is kind of going backwards from using the distributive property or multiplying two binomials together. So I'm going to show you the process that we do when we multiply two binomials, and then of course we're going to go backwards and see how they are similar. So let's just actually start with a case where we are not going to end up with a coefficient other than 1. We will end up with just 1x squared. But I just want to do this to really make clear how we can go backwards to factor. So I'm going to use this more simple case first, x plus 4 times x plus 3. So I'm going to, of course, take my first, and in this case, I'm really going to want you to think about how we do this multiplication using the distributive property horizontally versus doing the matrix. If you do the matrix, that's okay, but it just makes it easier to see, in this case, how the factoring is kind of the reverse process of doing this multiplication. So I'm going to start with the first term of the first binomial and multiply that by everything in the second binomial, x plus 3. And then I'm going to take the second term in the first binomial, that's positive 4, and multiply that by x plus 3. So I've taken this first term, multiply it by the whole thing, second term, multiply it by the whole thing. Now, of course, I just do the distributive property within each of these little pairs. So x times x is x squared, and x times 3 is positive 3x. Then 4 times x is positive 4x, and 4 times 3 is positive 12. And then, of course, after that, I could combine like terms and get x squared plus 7x plus 12. Okay, so now we're going to factor this resulting quadratic. I'm going to write it over here, and then we can see exactly how we'll do it in a way that's opposite of what we did here. So I'm going to start with x squared plus 7x plus 12. I'm going to ask myself, just like we did before, what two numbers multiply together to get 12, but add together to get 7. And on the side over here, I could make a note to myself that 3 times 4 equals 12, and 3 plus 4 equals 7. So I know that those two numbers will work. Okay, so now I'm going to do rewrite this. Instead of jumping straight to that final pair of binomials, I'm actually going to write out the same quadratic, x squared, but I'm going to write out the breakup of the 7x into the 3x and 4x. So I'm going to write 7x squared plus 3x plus 4x plus 12. And so you'll see why I did that in just a minute. Okay, so here you go. We just took that 7x and rewrote it as the sum of 3x and 4x. Nothing's changed as far as the value goes, right? Just writing it in a different way, that's going to be useful. Okay, now I'm going to actually just look at these two terms together, and I'm going to look at these two terms together. And if I do that, now if I just look at these first two terms, x squared plus 3x, in fact, let me go ahead and cover up those other two. If I just look at those, and I think about what monomial could I factor out of this binomial? Remember way back like 2 weeks ago, we factored out monomials. So I just see what is the greatest common factor of these two terms. Well, this one has x times x, and this is 3 times x. So the only thing I could factor out of both of them is x. So now I'm going to rewrite this as x times x squared divided by x, so I'm left with x. 3x divided by x is 3. You see how I did that? I factored out one of the x's from this pair of binomials. And then I wrote that x on the outside, and the result, what's left over inside after I divide out or factor out that x, is x plus 3. Okay, so we're going to do the same thing with the other pair of binomials. I see 4x and positive 12, and I might think to myself, what number could I, they don't both have x's, so I can't factor out any x's. But 4 and 12, the greatest common factor would be 4, right? 4 is divisible by 4, and 12 is divisible by 4. So I'm going to factor out a 4. So I factor out that 4, which means I write it on the outside of the parentheses, divide the terms inside to get what's left over. 4x divided by 4 is x, and then 12 divided by 4 is 3. So now I've written this pair as the product of 4 times x plus 3. Now you could see we have x times x plus 3 and positive 4 times x plus 3. Now what you do is you factor out that x plus 3 and rewrite this as x plus 4 times x plus 3. So even though previously we found this pair of numbers, right, and we started with our quadratic, found this pair of numbers, 3 and 4, multiply to get 12 and add to get 7, and we could jump down to that step, I wanted you to see that how exactly we really are going backwards from this process. So you can see here the result was my two binomials that I started with here. And here the result was the quadratic that I started with here. So once I have this quadratic, I then broke it up into those two. I still had to find those two numbers, but I broke up that 7x into its two parts, 3x and 4x added together. And that allowed me to, now this looks like this step here, right? So it's kind of still going backwards. Now that allowed me to group, so we call this grouping. I grouped the first two terms together, and then I grouped the second two terms together. And then I factored out this x, and you can see that now this looks like this step here. I factored out the 4 out of these two terms, and this looks like this here. So just as we took the first term of the first binomial and distributed it through, we could take out that term out of this pair and make it the product of that times that second binomial. And if we do the same thing here, we factor out a 4, we end up with x plus 3 here. And then this I can turn into what we started with, our two binomials. This is going to be the first term of our first binomial. This is going to be the second term of our first binomial. And then here, both of these parts, these groupings, reveal the second binomial in our factoring. Okay, let's look at another example where, in fact, the leading coefficient is not 1 and see if this makes sense. Okay, so we are going to do 3x plus 4 times 2x plus 1. And again, I'm going to go both ways because I really want you to see how it's the reversed process of multiplying two binomials. So we're going to take the first term of the first binomial, 3x, and multiply it by the second binomial, 2x plus 1. And then we take the second term of the first binomial, plus 4, and multiply it by the second binomial. And then we use that distributive property like we did before. 3x times 2x becomes 6x squared. 3x times 1 is just 3x. Now we have positive 4 times positive 2x, so it becomes positive 8x. And then positive 4 times positive 1 is positive 4. So now here I have my x squared term, I have my constant, and I have two different terms that just have the variable x. And then I'm going to combine those together. 6x squared plus 11x plus 4. Okay, now let's see if we can think through the factoring of this resulting quadratic. 6x squared plus 11x plus 4, and see how it's similar, or see how it's the reverse process of doing this. So here we go. We're going to now, instead of just looking at what two numbers equal the constant, what we have to do is figure out what two numbers multiply together to get these two numbers multiplied together. Whew, I don't know if that made any sense. First, let's identify our coefficients and our constant. We're going to say that a equals 6, right? That's the coefficient in front of the x squared term. B equals 11 and C equals 4. Okay, now I'm going to figure out what A times C is. A times C. So A times C is going to equal 6 times 4, which equals 24. Now what I do is figure out what factors of 24 add together to get 11. So we're going to do factors of 24. Previously, we just did factors of C. Well, previously, A was always 1. So C times 1 is just C. That's why we could get away with just doing factors of C. Now we're going to do factors of C times A. In this case, it's 24. And so you might, if we didn't already know, you might think, oh, 2 times 12 equal 24, but those add together to get 14. And you might think, well, 6 times 4 multiply together to get 24, but they add together to get 10. And eventually you'd probably come to 3 times 8. And 3 times 8 equals 24. Of course, 3 plus 8 equals 11. And this is the pair that we're looking for because we want the sum to be equal to b. Okay, here we go. Now we're going to rewrite 11x. We're going to rewrite it as 3x plus 8x because we know that that's the same as 11x. So we have 6x squared plus 3x plus 8x plus 4. Now we're going to do what we call grouping. So we're going to group these two terms together and group these two terms together. Now I look at these first two terms together and I ask, what number can I factor out? What monomial can I factor out? Because it could include a variable. 6 and 3 have a greatest common factor of 3. They're both divisible by 3, and that's the biggest number that they're both divisible by. And because I have x squared and x, I can also factor out an x. So I'm going to factor out a 3 and an x. And I'm going to rewrite this as 3x times whatever the result is. 6x divided by 3x leaves me with 2x, right? 3x times 2x would be 6x squared. 3x divided by 3x, well, that just leaves me with 1. 3x divided by 3x. Number divided by itself is 1. Here I have 8x plus 4. What number could I factor out? I can't factor out any variables, so I don't need to worry about that because this term does not have any variables. But I can factor out a 4. So I'm going to rewrite this as 4 times 2x plus 1. Okay, now I have the first term of my first binomial times the second binomial, and the second term of my first binomial times my second binomial. So I can rewrite this as 3x plus 4 times 2x plus 1. Now, you might have come up with 3 and 8 and put them in a little bit different order. If you'd put the 8 here, 8x here, and the 3x here, then you might have gotten a little stuck as to what you could factor out. Maybe, maybe not. Sometimes it works both ways, right? So either way, if it doesn't for some reason come out with a binomial from both groupings that's the same, like 2x plus 1 and 2x plus 1, then you might just have to reorder these or think about a different number. Okay, so here we go. That's the answer there. And just to compare again, here we started with the two binomials. We multiplied the first term of the first binomial times the second binomial, and the second term of the first binomial times the second binomial. And here is we have the same thing, the first term of the first binomial times the second binomial, and the second term of the first binomial times the second binomial. And we got that by grouping together these terms after we split up 11x into 3x plus 8x. And we figured out 3x plus 8x because we first multiplied the coefficient in front of x squared times the constant at the end. That's a and c. A times c is 24 in this case. So we're looking for factors of 24 that add up to be 11. And we got 3 and 8. All right, this is the process that we're going to do these. So first practice thinking about what those different steps are, and then we'll do a couple more examples.